All right, the last section in 2.1 is transforming data. So we did this activity in class, but since we're not in class, I'm just going to have you put some data in your calculator if you want to follow along. Estimate the length of the room in yards and write it on a slip of paper. Turn it into Mr. Blackburn. After he puts the data on the board, put the data into your calculator and describe the distribution. So we can't really do that because I don't have the data or we don't have a class. So if you want to follow along, go ahead and pause the video, call the variable guess, put this data into your calculator, and we'll analyze it. I've already put it in my calculator. It's under guess, and we'll just start from there. So describe the distribution. To describe the distribution, we're going to cuss, center, unusual features, shape, spread, whatever order you want to do it in. So to see the distribution, I'm going to open up a new page, and I'm going to make a dot plot. So I kind of see a couple peaks. Some people might say that's bimodal, but no, I think it's just kind of random chance. So I'm going to say unimodal. Looks like it's skewed a little bit to the right, but not a lot. If we looked at a box plot, you visualize that whisker going all the way up to here. I'd say slightly skewed right. So I'm going to say unimodal skewed right. I can see the median is 28, and the IQR would be 31 minus 22, so we'll call that 9. So, excuse me, center. The median guess was 28 yards. There was one unusually large guess of, what was that outlier? 50 yards? Come on, my room's not 50 yards. For spread, I'm going to say the IQR of guesses was it 9 yards? And the shape was the distribution of guesses was unimodal. Let's say slightly skewed. Skewed to the right. Slightly skewed right. Okay. So I'm going to tell you the true length. So I'm just kind of making this up. I'm going to say the actual length of my room is 21 yards. I'll actually measure it when we do it in class. So let's define a new variable called the error by taking each guess and subtracting the actual measure. So the error is the guess minus the actual. In this case, the guess minus 21. So the error for this outlier would be 50 minus 21, which is a positive 29, indicating that they were 29 yards over the actual. So this is called transforming the data set. We're subtracting a constant from every single data point. So the question now kind of should be, how does subtracting a number from every single data point affect the measures of center, the measures of spread, and the shape? So maybe if you want to pause it and kind of think about that, I guess you can. But basically, if we subtract 21 from every single data point, this data point is going to go 21 over this way, so it'll be negative 11. This one's going to go, everything's going to be shifted 21 units to the left. So the minimum is going to be 21 less, the median is going to be 21 less, the mean is, every measure of position is going to be 21 less. However, the spread isn't really going to change because the entire distribution is going to be shifted over. Also, the shape isn't going to change. So you're still going to have these little peaks here and little spaces and gaps and these outliers. So the answer, I guess, is these will be 21 less than the original. These will not change. And these won't change at all. So then I think we're going to illustrate that. Do the transformations on your calculator to test your hypothesis. So I'm going to make a new data set called error. And I'm going to put it to the cell and hit enter. And let's actually take our initial guess and subtract 21 from it. So you can see all of these are shifted 21 over. I could make a new graph, but I actually just kind of want to add if I go to menu, plot properties, let's add an X variable. Let's add the error to it. So as you can see, each data point is 21 less than the original. The entire distribution is shifted to the left. So the centers are going to change, but you can see the spread is going to be exactly the same and the shape is exactly the same. And if we actually ran I guess we could look at a box plot. If we actually ran the statistics, 28, 7, that's 21 less. 50, 21 less. Everything is going to be 21 less. 11, negative 10. However, the IQR is going to be 10 minus 1. That's 9. 31 minus. So I guess that kind of supports our hypothesis. The effect of adding or subtracting a constant. If you add the same positive number or subtract the same number from each observation, this adds or subtracts that number from all the measures of center and location, mean, median, quartiles, percentiles, but it will not change the shape of the distribution, nor will it change measures of spread like the range, IQR, and standard deviation. All right, so that's adding and subtracting. Now, suppose we convert the original data, which was in yards, into feet. In order to do this, we simply multiply your original guess by 3. So here's a new variable. This is going to be error. We should call this like feet or something. A new variable feet, which is 3 times the guess. But this is a multiplicative transformation. So how do you think this is going to change the measures of center and the measures of spread and the shape? So again, maybe pause the video and think about it. See if you can kind of figure it out. All right, so I'm going to make a new graph. And I'm going to plot my original data. It's a dot plot. These are the errors. Oh, I'm sorry, the guesses. I want to put the guesses in. There's the guesses. So let's make a new data, a new variable, calling it feet. And we'll test your hypothesis if you made a guess at it. So let's make a new one, which is going to be 3 times your original guess. So as you can see, the person that guessed 22 is all now up to 66. So let's plot this data set on the same axis, menu, plot properties, X variable, and let's add that feet guess. So here's the original guesses, and here's the feet guesses. So the center has changed. It looks like was about 25, and now looks like it's about, I guess, 75. Let's look at the box plots. We went from a median of 28 to a median of 84. I believe that's multiplying by a factor of 3. So the centers are multiplied by 3. The min multiplied by 3. The outlier multiplied by 3. So all the measures of position are multiplied by 3 like you might expect. But notice the spread is different. I mean, this is pretty narrow, and this looks like it's 3 times larger. Since the bottom value was increased by 3 and the bigger value is also increased by 3, it does increase the spread by 3. So it does stretch it out more. So spreads are going to be multiplied by 3. Now the shape. And I think if you guys look at this, you might think that the shapes are the same. Or excuse me, are different. Because they don't really look the same, but it's because of the scale. Like if I have this one spread out like this, it looks exactly like this. Take a mental picture of that. And then if I were to make, if I were to spread this out, so this one was scaled the same, that's like the exact same picture, right? So the shape doesn't actually change, it just gets compressed. But that's not shape. Compression is a change in spread. So the distribution shape is actually going to be identical, and I guess maybe we could see that with the box plots. See how this is, okay, this one's a little longer, it's got an outlier. The median is a little bit closer to the Q3. That the shapes are identical. So how does this change this? It multiplies every value by 3. How does it change spreads? Multiplies by 3. How does it change the shape? Doesn't change. So in summary, if you add, it changes measures of position, but not spread and shape. If you multiply, it changes centers, position, it changes spreads, but it doesn't change shape. Summary, multipliers, if you multiply by something, it multiplies or divides the measures of center location, multiplies, divides the measure of spread, but it doesn't change its shape. Okay. So an example here, and well, we got about 4 minutes. Can we get through this? A taxi cab driver has discovered that the length of his fares are skewed right with a mean of 4.2 miles and a standard deviation. So we'll call this length. So we have a variable called length, and the mean of length, L bar, we want to use a sample mean, is 4.2 miles. And S sub L, the standard deviation of length, is 4.1 miles. And the distribution is skewed right. So there's the shape, here's the center, and here's the spread. The driver charges a set fee of $5 for each fare and then charges $2 for each additional mile of the fare. Describe the distribution of costs. So now I'm making a new variable, costs, which is going to basically take my length variable. I'm going to multiply the length by 2, because I charge $2 per mile, and then I'm going to add $5 to it. So I'm going to take 2 times L, and I'm going to add $5 to it. So this is what my cost variable would look like. So I'm doing 2 things to the length data set. Multiplying by 2, adding 5. So let's describe the distribution of cost. Well, the center. Well, this was the mean of my original distribution. Basically, the means, it's just going to be exactly what you'd expect. If you add to the mean. If you multiply the mean. So I'm going to take 4 point, oh, I'm just going to write it down. You got to show your work here now. 2 times the old mean plus 5 means my new mean is going to be at, what is that, 8.4 plus 5. Oh, I'm not very good with 8.4 plus 5. So 13.4. And it's going to be in dollars. This is going to be the equals the mean. I guess I should use better notation. C, cost, center. All right, looking at the clock. C bar, that's equal to the mean. Spread, this would be S sub C. Now the spread is not going to be affected by the addition of the 5. It only is affected by the multiplier. So I'm just going to take the 4.1 standard deviation and double that. So that's going to be a standard deviation of 8.2. That's equal to the standard deviation. And then the shape doesn't change. So if it was skewed right before, it's still going to be skewed right. So that would be my answer. And it didn't say anything about outliers, so I guess I don't know. So the new center is going to be twice as big, 5 times plus 5. Spread is only affected by the multiplier, not by the addition. And shape's not affected by anything. All right, looking back to z-scores. I'm going to run out of time here. Maybe just kind of read through this. Like I said, we talked about it in class, but basically whenever you transform z-scores, you subtract the mean and divide by the standard deviation. So what that's going to do is, it's going to change the mean, the center of your distribution, to 0, always. And it's going to change the standard deviation to a value of 1. And the shape, is going to have the exact same shape as your original distribution. So that